Alright guys, welcome to another video, and in the previous video we explored numerical Python. In this video we want to explore pandas. And pandas simply means, like when we look at the full meaning, just like NumPy numerical Python, pandas simply means panel data. Okay, that's just what it is. Let me take all of this out. Just put it as panel data. Into brackets, pandas. All right, so that's all we have on numerical Python, which we have covered as NumPy. Okay, let's collapse NumPy. Now, what is pandas, or what do we want to do with pandas? Well, it's one of the libraries of Python, and just as we mentioned, or just as it has been emphasized when we're looking at NumPy, is that it is built on top of NumPy. Okay, pandas is built on top of NumPy and is designed for data manipulation and analysis. It introduces two major structure, right? One is the 1D array, and the second one, 1D is the series, and the second one is DataFrame, which is the 2D array. Okay, or table. Majorly we call it table. It's a single one, it's the array, and now we can call it table. So why should we learn pandas? How powerful is pandas? What can we do with pandas? It gives us the feel of Excel and SQL table, right? Because it's in rows and columns this time. We can see just like we have a spreadsheet, or just like we have an SQL table. We have labeled axes, right? That means we can access data by the labels. We can access data by the labels. For column names, for rows, we can just use the indexes or indices, right? Index of the rows. Okay, you can use it to undo missing data, which is very powerful. Or majorly, let's just use the word data cleaning. Handling data cleaning, it is very fast to clean up data, regardless of the number of data you have or the amount of data you have, regardless of the volume of data you have. Pandas is very fast for data cleaning. Okay, we have grouping and aggregation, right? Something we're already used to. And there's a spice after grouping and aggregation that you see shortly. So just make sure you stick to the end of the video. It makes you, now, if you ever have intimidation, probably you've learned Python before, majorly pandas, and you still feel intimidated, by the end of this video, all of those things will be a bygone, right? We also have time series functionality. You can use it for time series data, and it can integrate with NumPy and other libraries that we have. Okay, so a series is just like a single Excel column, right? Single Excel column, while data frame is the entire table itself. So let's see what we can do. Let's just create a panda series, then we jump into the data frames, where we'll do much more. Okay, all right, let's just get started. First of all, let's import libraries, and in this case it's just good to have NumPy imported as well. Okay, so import NumPy as np, the alias, and import pandas. This way we'll give it also an alias as pd. This is the general convention. Okay, so let's just execute that. So we'll let that connect. All right, we're good. Let me create a new cell below. All right, so now that I've imported pandas and NumPy, we can now create a series. So we're starting with a series, And a series, as we already know, is just a single 1D array. But compared to NumPy, this can hold any data type, right? Integer, string, float, object, etc., etc. So it can hold any data type at all. Okay, so let's just create a series. I'm gonna call it calories. Okay, let's say someone is tracking his or her calories, and today is like the third day, and they have been tracking, or just say after a week, right? That makes more sense as though after a week. So we want, let's say, day one, or maybe they're just tracking for the morning period. So calories morning, I'm gonna say 390. We can also say 650. Let's say they had this spike at this point, then we'll say 470. All right, Monday to Friday. So they're doing a check on a Saturday morning, right? So this is just a simple list. So we have to say my series. Then we can convert that to a series by saying PD. If it was to be an NP array, we just do np.array, but in this case we do pd.series. And pay attention that series in this case starts with a capital S. Do not make that mistake. It starts with a capital S. Okay, so in here we can pass in calories. Let's say creating a series. Creates a series. All right, so we have pd.series right there, and then we can print it. I'll say print, as usual, f string for the double quotes, then series from list. My series. Okay, we have my series, and then just to check the type, let's say type of my series. Okay, so let's start with these and print. Let's print this first. I'll be using Alt Enter to print so that I can create a new cell for us at the bottom. So Alt Enter. So that created a new code cell for us at the bottom. And you can see that this is what we have. So we have, see where I started from. So I think I should do a \n. All right. So I'll just do a Shift Enter now. So it jumps to the next cell. So you can see series from list. Oh, no, not before our semicolon. So \n twice. All right. Let's see how that looks like. Okay, good. So this is what we have. And we don't want this space. We also want a space before the type. No. Yeah. Just \n. Okay, this is part of this, so put it right after this guy, \n. So run it again. So this is what we have. So it's showing us we have the series, and you can see that it's saying the type. Majorly, let's look at the type. It's saying is a series.series, Pandas score series. So this is what we have, and this is what a series is, just a single row. And you can see that the index or the just as you see here, the row labels are what are the index, right? The row label are index 0, 1, 2, 3, 4. That is what we have in there. So now let's create a series with a custom label. Okay, This one just has the index as the label. So let's create another one, custom label, series with custom label or labels, right? So when I say labels, then we can say that will be Monday. Okay, I think this should just be a list. Since it will be a list, we'll just use our list method. So Monday, Tuesday, Wednesday, Thursday, Friday. Okay, so now the actual series, which is what we now want to do, we want to create a series that will hold the value. Do not forget that this will be the labels instead of saying things like 0, 1, 2, 3, 4, 5. Right, I've decided to change the labels to a text, okay, instead of the default index that we get before. So we'll do a calorie count. So say calories count. Let's just use CNT. Will be pd.series. We can pass in our list here directly. Okay, pd.series, and then we have it. Open a bracket. The first thing is what did we name it? Calories, and then we'll pass in index. Now, do not forget, you can see it says you pass in an array, then you can pass in the index, you can pass in the data type and all of that. So we want to pass in the index, and then we'll say the index will be labels in this case. Okay, so let's print this out and see what it looks like for us. Index, labels, let's just say axis label. All right, let's leave that and print this directly. This is a list. Yeah, calories is a list. Let's run that first and see what we get. Oh, okay, I omitted the splits, right? Just right here, I omitted the split, so this is not being seen as a list. I just typed and I didn't even remember to put it. So it's saying, oops, this must be callable some kind of value that we can over. So let me do a split right there. All right, you can see now that the error has gone, the red underlined version. If I take it out, so Python is now Colab is able to detect that, okay, there's going to be a problem in advance. So and put it back, and it's going to take this out. So the next thing is that I want to print. I can just copy this and say labeled series or axis series, whatever English that will be. We'll paste that. We want to remove this. We don't want to print the type again. And we'll call this series with custom index. We can just say series with custom index into brackets row labels. Okay, so this will be calorie count, calories count. Okay, and that's what we have. So let's print that out. I think one should be fine just here. All right, so I want to print this. Are we missing anything? I think we're good. So let's execute it. And yeah, you can now see how it looks like. So series with, oh, I think I need another one. All right, so series with, run that again. Good. So we have series with custom index, which is row label. So we now have Monday, the calorie count, Tuesday, Wednesday, Thursday, Friday. So instead of just having the 0, 1, 2, 3, 4 and all that we have, we now have a better way of viewing it. So let's look at how to access elements in. Excuse me. So let's see how to access elements in series. Okay, do a code, and then we'll say accessing or access elements in series, or in a series. Series is pluralized, so just keep it that way. So we can say, let's say we want to check how many calories was consumed on Monday. So we can say F calories consumed consumed on Monday morning. The calorie consumed on Monday morning. Let's put this looking weird. Monday morning. Then we'll put this and then we'll pass in the value. Now we want to access just the Monday calories only. Okay. So we'll put in the variable name first, which is calories count. Auto suggest, okay, calories count. Then we'll open a square bracket, open a quote, then inside there, single quote or double quote, inside there we can now type in the particular one we want to access. So we can say Monday, just like that. So we can say Monday just like that. So if we hit enter, let's just do control enter so it stays there. You can see it has been able to grab Monday calorie. So what about we say Friday calories? You can see 470. It has been able to grab the one for Friday. Okay. So let's put that there. So yeah, now we change this to Friday, Friday morning. Okay. So what about calorie consumed on the first morning? On the first morning, right? The very first morning. So on the calories count 0. In the load, and you can see it has been able to do what? To grab the calories for us, right? Calories count 0. So using the 0 index is grabbing, it's able to use the index to get it for us. And by the way, this is just a warning. And if you read the warning, it says future warning. So it's a future warning. It says series.getItem treating key as positions. It says deprecated. It says in future version, integer keys will be treated as labels consistent with data frame behavior, right? So to access value by position, we'll have to use series.ilock, but we'll still see the high lock and the lock in data frame once we get into it. Okay, so it's just a warning. Nothing is wrong. Okay, where are we? Okay, oh yeah. So we have been able to do what? We have been able to see, let me scroll. Okay, we're not scrolling, everything is visible. Yeah, so we have been able to grab a particular value or an element in a series. Okay, so next up now we want to look at data frame, and this is where we'll now start looking at things that look more like spreadsheets. We have rows and column. We want to work with CSV files. We want to do some advanced manipulations and all of that. So let's just jump into it. All right, now let's take a look at the data frame and we'll expand this. Just like as we have seen, series is more like a single Excel row column, while data frames are more like entire Excel worksheets, right? A Pandas data frame is a 2D, two-dimensional data label data structure with columns of potentially different data types. It's like a spreadsheet or a SQL table or dictionary of series objects. Okay, so we'll just jump into creating one without wasting time. So we'll create a data frame right here. We already imported NumPy and Pandas, so we can go ahead and use them. We don't need to re-import again in another cell. Okay, so we can just say data. So this will be a dictionary first. Okay, so we'll have name, and then we can have it as list. uh, Alice, Bob, Charlie, Darwin dot split. So this gets us a list. Okay, then we'll have the age of those people. So in this case, we can just maybe make this capital, since we want them as column name, but it's fine as lowercase as well. So what are the ages? We just put in 25, 30, 35, 28. You're probably expecting 40, right? Just break the pattern that way. So city will be New York, London, and New York again. Since we're not using abbreviation, so let's type that in full. Of course, in this case, it will split the way I don't want it to split, except we do New York this way. All right, New York. So we'll just keep it as NY. Okay, keep it as NY. Then we can maybe manipulate and update that later. Split. So this is what we'll have, and we'll print this first. So let's see what we have, because it's good to step by step see what we're doing. So this should be a dictionary. So we'll run that. Okay, so we can see what we have. It's showing us as a list, proper list. The age is there and everything we need, which is fine. All right, let's take it out now and convert it to a data frame. So we'll say df, which is more of a convention, is a variable name, but is a convention popularly used in Python when working with pandas. Df is just data frame. Okay, then we'll say pd dot, the same way we have capital S is the same way we have this to be Pascal case. Okay, so it's data frame. D is capital, F is capital as well. Then we'll pass it in data. Then we can print the data frame. Just say data frame from a dictionary. Then we'll pass it in that way, df. So we can give it a backslash n, just like that. So if we run this, you can see how nice it is looking, right? Data frame. If we print it like this on its own, okay, send is running. You can see we're getting a better feel of it, and you can see we have some AI suggestions. You can see convert this to data frame, says to an interactive table, right? Just AI features right there. You can see what it looks like. Why did it print twice? So in that case, we can just do this instead. Take it out from here, since that looks nicer than this. Okay, just print it normally. So printing this, and then we're doing, okay, so data frame from dictionary. And you can see we have the name, the age, and the city, just like an Excel spreadsheet. You can see how nice that is looking. Okay, so feel free to explore the interactivity of what we have. We'll just proceed with the next thing. So let's say we want to get the first few rows. We want to see what is inside our data. We can do df dot ed. Okay, df dot ed. Usually ed gets us the first 5 rows of data, and our data is not even up to 5, so you can see it's getting us everything at once. So we can put in a number here, and let's say just the first row of data, df1, and if we run that, so we're getting just the first row of data. If we want to get the first 2, we can run it this way, and we're getting the first 2 of the data. The same way as you have ed, you also have tail. Okay, so let's see how to add a tail. Tail just gets the last few rows, so it depends on the number of rows you want. So we'll just say df.tail, then we can pass in the last 2. We run that, and you can see it's getting 2 and 3, just like that. Okay, let me close this. Let's add more code cells here just to do a few things. So that is it. What I want to find out about our data, right? Let's see if we want to find out about our data. So we can just do df.info, open and close the brackets, run this, and you can see this gives us a quick summary about our data. It's telling us total columns 1, 2, 3, 3 columns, and you can see them. For the columns, we're seeing the name. It's showing us the total number of null, and saying for non-null, and it's showing us the data type of the values in individual columns. Okay, all right, so that's how to do a quick check of what we want, right? Just to find out about our data or get to know our data. So what if we want to get the numerical statistics, right? The descriptive statistic for our numerical columns. We can do that using df.describe. df.describe. Then we'll execute that, and you can see what we get. If we print it, we get all this funny look. Okay, so we'll get all this funny look. Now we can see count. It picks the numerical column by itself, right? So it's just telling us that this is the age column. We have 4 values in there. This is the mean. This is the standard deviation, the minimum, 25th percentile, 50 percentile, 75 percentile. Okay, you can say Q1, Q2, Q3, things like that. And this is the maximum value in there. So that means the highest age or the oldest person is 35, right? And if we look back at our original data, that is correct, and that's Charlie. Okay, so that is Charlie. All right, now let's see how to access column. Okay, access columns. We have 2 methods. The first method is what we'll be using, but the second method is just so you know it. Okay, so we can say df, then square bracket, then we'll pass in the column we want to get. So if his name, if his age, if his city, for example, we'll pass in city that way. Then if we run that, you can see we're grabbing the city. The same thing we can do the dot method of it. So dot city, but it's not, why this is not a good practice is we use other methods using the dot notation, so it's not advisable to use this to grab the column. Let me comment this out, the columns. Okay, so if we run this now, you can see we're getting exactly the same thing. Okay, we're getting exactly the same thing. So what about we want to access multiple values? You can say df accessing multiple values. So in this case, we want to do print. Oh, okay, not printing so far. We can just do df. Then we'll pass in, as usual, a list of lists. In cases where we're using NumPy, we pass things as tuple. So in this case, we pass lists. Okay. So we'll then list out what we want to get. We want to get the name. We want to get the city. Let's say we just want to get the name and the city. We want to see the names of people and where they live. So we run this. It grabs just those two for us, right? Just grabs those two for us. So with this, of course, there's still more to do with it. And yes, they are just in right here. So for now, we have seen this is more like an introduction to DataFrame. In the reality of it, we'll be working with an actual data, not creating all of this from scratch. But sometimes when we're trying to grab data online, maybe web scraping or different sources and all of that, we might need to convert this data in this way. If it's just a small use case data, but most times we can just connect this to the database. That means we save the data into the database and then we can work with it. So I'll just take out these columns. So take them out, take out, collapse this, and then we'll jump into some hands-on for pandas. So close up,